Today we are meeting with Maurizio Motta, who's the wind energy consultant at EMIDI, and he's going to tell us more about the advanced curtailments in windPRO software. So Maurizio, the floor is yours.
Thank you, Alexandra. Hope you hear me clear and loud. End of the conference and end of the day. So hopefully there will still be someone out there hearing me. The presentation today is about curtailments in our software windPRO. And of course, it somehow implies that you are windPRO users and affectionate in it. But just as a quick show off for those of you who might still want to join without being a windPRO user, windPRO is a leading software in designing and planning wind projects, and it covers a pretty large number of tasks, from the obvious wind data analysis and consequent assessment of annual energy production to the assessment of the uncertainties and losses for so-called bankable reports, the assessment of the suitability of a given technology to a certain environment based on the IEC standard, the estimation of the environmental impact in terms of noise, shadow flickering, and visual impact of the turbines. And last and certainly not least, the ability of doing detailed analysis of post-construction production data from an existing wind farm, which opens a lot of possibilities in terms of reassessing the power production, as well as doing the analysis of the performance of the wind farm. Enough for the pure advertisement, and we go straight to my presentation, which is how to handle curtailments in windPRO. What is presently possible in 3.4, which is the present version, which will be actually released in a few days, as far as I know. So it's really a matter of days to have the official public release. First of all, where are curtailments usable in windPRO? There's three main modules, three main places in windPRO where curtailments you may set up will be directly used. The most obvious one being the park calculation, which, as you know, is used for estimating the gross energy production of the wind farm. And we have in the curtailments taken into account, and therefore the consequent the corresponding losses. You can we somehow break the old tradition of having park doing only and strictly providing only strictly the gross production plus the wake losses. So now, once you take the curtailments on board through park, you can get the gross minus the corresponding, the possible curtailment losses, and of course the wake losses. Immediately next comes, of course, our module called Losses and Uncertainties, where you can import the park results, and thus the curtailments you have, the curtailment losses you have calculated in park will automatically be loaded as losses in order to estimate the total losses of the wind farm. Another crucial place where curtailments will be taken into account is our site compliance tool, which again is the module that allows to verify the suitability of a certain technology, a certain turbine, in a given environment based on the IEC standard. So obviously, if you curtail some or more turbines, this will affect this calculation. Quickly speaking, if your turbine is shut down for whatever reason and for whatever curtailment necessity, obviously the turbines behind will not be affected by wake added turbulence. That, of course, has an impact in this kind of calculation. Thus, you can avoid redundancies erroneous calculations, taking these curtailments into account, and thus having a correct result out of it. What kind of parameters can be handled in windPRO as curtailment sources? Well, you can see the full list there, and as we will be detailing later on, most of them can only be handled by time-varying park calculations. In terms of actions, as you already know, there's two ways you can curtail a wind turbine: a full shutdown, which is an extreme action, but sometimes it is needed, or in terms of noise reductions, of course, you can use different noise modes. And obviously, windPRO gives you the ability to switch between different noise modes or to apply a full shutdown. And talking about operation modes, just a quick review of what windPRO offers in terms of how handling operation modes. I believe all of you are quite familiar with the data sets we offer in the windPRO turbine catalog, where essentially we have the minimum information, which is the power curve, and the CT, the thrust curves. And together with them, we also offer from the manufacturers the noise data sets. And these things are there, and they've been there for quite some time. Less known is the fact that you can actually pair or couple these data sets in order to respect the link that a certain power mode has to a given noise mode. So the so-called, here you can see an example. So what we call in windPRO the level 0, level 1, and level 2. In the first scenario, basically have to manually switch, select a certain power curve for running energy calculations, and you'll have to manually select the corresponding level mode or mode in terms of noise in order to run a noise calculation. And this is, of course, prone to mistakes. So by coupling this and thus linking these data sets one to each other, you make sure that your selection for energy and noise impact calculations will be safe, because you know what you are going to select, because it's automatically, those data will be automatically coupled. The most recent addition to our family of data sets is what we call the power matrix, which is a very powerful tool because it's essentially a multidimensional matrix containing still the standard, the so-called expected power, thrust curves, and noise data, but they are also provided for multiple air densities. And there's a lot of other climate variables that can be included, such as turbulence intensity, wind shear, veer, vertical inflow angle, and so on. So it's up to the manufacturer to provide us in this special format these data sets. And of course, these formats become particularly useful if you run in the time domain an energy calculation, because windPRO, for example, having time series of temperature will be able to estimate the corresponding air density as it varies in time, and thus pick from the correct power curve pool what is the correct power curve to be used in that specific situation. Back to curtailments in particular, once again, I would like to stress that of all the available parameters that you have quickly seen the list of at the beginning, only two are available if you run in the so-called standard good old WASP approach, which is based on wind statistics. And those two parameters are, of course, wind speed and wind direction. All the other parameters are instead available to time-varying calculations, as long, of course, as you have the corresponding time series, because that's the requirement. there's a few places in windPRO where we still have no use of the curtailments. And these are decibel, the module to calculate noise impact, and shadow, which is the module to calculate shadow flickering impact. What this means essentially is that if you set up the turbine, the curtailment, some curtailments in your turbine for whatever reason, these two calculators will not be able to see the turbines shut down or inoperative. So they will still provide you a result which is independent from any curtailment you may have applied. Obviously, both these environmental impact assessors can be used instead to assess the need for curtailments, and that's basically their primary use. And you can also apply curtailments through them, because you can estimate how much noise, for example, certain turbines are giving, and therefore you are able to actually optimize their noise emission by reducing the noise emissions, changing the mode. So this is obviously always been possible, and it is there. So it is work in progress. As I said, the next edition is coming in a matter of days. So I believe it's a matter of waiting until the further edition, which would be windPRO 3.5, before we can get those things done. Operationally, how can you actually work with curtailments in windPRO? There's a number of places, as it is often the case, where you can handle curtailments, where you can enter curtailments in windPRO. The most obvious one would be being, of course, the single turbine object. You can see an example in that screenshot where basically the user has already defined in the turbine object in the new tab called Curtailment some noise curtailments, and is actually now in this second window adding a second rule that concerns wind sector management. So eventually this turbine will have at least two curtailments. And what you do is basically to create a number of rules under to define each curtailment. I will show you in a brief presentation after the PowerPoint how you can actually do this in windPRO. Being familiar with windPRO, you'll also know that you can do multi-editing, and multi-editing is particularly useful in this in handling, for example, multiple turbines which share the same curtailments. So what you can do is you select multiple turbines, right-click and open multi-editing, and this way you'll be able to, as you can see here, apply same curtailments to a number of turbines. The lists of curtailments can also be exported for later use and or imported later on. Last and certainly not least, there's another place where you can handle curtailments, which is Park. So when you run Park, if you want to use curtailments, of course, you'll activate in the Setup tab the option Use Curtailment. This will activate a specific tab. And in there, you'll have not only the option to simply review what you have done in the single objects before, so the curtailment of the different turbines, but as a last chance, as a last minute, you can also still modify those curtailments if needed. windPRO will also warn you in case some of the signals may be missing, or for any reason some curtailments cannot be calculated. The calculation will run anyway, and basically those specific curtailments will not be taken into account, will be ignored, but you'll receive a warning on that matter. In the next couple of slides, I would like to simply show you how to read and interpret the results out of windPRO. We'll start with some very trivial examples and go a bit more complex to try to understand how the software interprets and uses and calculates and returns the curtailment losses, essentially. Let's start with the most trivial scenario, with basically we have two machines and no curtailment whatsoever. So we have a certain wind speed impinging in turbine number one, obviously no wake losses. Out of it, the wind speed has probably changed because of its presence. And once it will reach number two will experience some wake losses due to the presence of number one. So, and for example, 8% losses. Not having any curtailments, that's pretty much it. Let's imagine now that instead we shut down and we curtail number one by a full shutdown all day. Well, in that case, obviously, number one will be affected by a 100% curtailment losses. What happens at number two is that now number two is free to receive the unperturbed wind speed, and so in this case, number two will experience zero wake losses compared to the previous scenario. Again, pretty easy. The third scenario is that we curtail both machines, number one and number two, but by 100%. So basically, we shut down both of them. And once again, it's pretty trivial. If they're both shut down, so what will happen is that number one will experience 100% curtailment losses, and number two will experience exactly the same situation. So 100% curtailment losses will be returned for both of them. Things get a bit more interesting if you consider this scenario when you actually curtail number two. So in this way, again, we have number one receiving the full wind speed, 0% wake losses, and part of the wind speed comes out of it and it will impinge in number two. We already know that with that wind speed, number two will give me 8% wake losses. But we curtail number two by shutting it down the whole day. So at this point, the question is, what is eventually the curtailment losses resulting in in number two? Because of course it essentially depends on the way you prioritize these things. Since we shut down the whole day, it could be 100%, but there's also wake losses. So what is the right answer? What should I expect from WindPRO out of this? And the correct answer for WindPRO is 92%. In other words, we prioritize the wake losses. This turbine with that wind speed, due to the presence of number one, will have an 8% wake losses. But since we shut down the machine for the entire period, the remaining 92% is what we lose due to that curtailment. And that is indeed the curtailment loss provided by WindPRO in such a scenario. Future prospects, to conclude. In later versions, as I already mentioned, we would like to have the ability to feed curtailments setups in decibel and shadow so that these two modules take into account the fact that the turbines may not be running for any other reason. Another thing which we would like to have is the ability to consider grid curtailments. So if the turbines must be curtailed because of limitations, technical or market limitations of how much electricity you can feed into the grid, we would like to also have this, the possibility of adding this thing. And last but not least, we are planning even a smarter and more friendly graphical handling of the curtailments. So a manager that can help, that it can make even more fun to enter and manage and analyze the curtailments in WindPRO. That is pretty much it. I would like then to show you how all this is done in WindPRO in a brief presentation. I have here windPRO just behind. So you can see this scenario here. I have 4 machines there, good old Vestas V90 2.0. They are clean, no curtailments yet, but we can apply a few. For example, I know in this environment the main wind direction is coming from east. So you might have some nasty interference between these 2 turbines. So the manufacturer might tell me we have to shut down this machine or the other one for easterlies. So what I do is I select the machine, right click, open its properties, and in here under the tab Curtailment, I'm able to add a rule. And in this case, what we're talking about is wind sector management. And this will typically occur for relatively high wind speeds, for example, starting 15 meters per second, and only for the directions which are really affecting these turbines. And I know the angle between the two, so what I know that we should curtail for angles which go between 100, for example, and 120 degrees, because that's the exact angle seen through which these machines see each other. And what we do is we simply shut down fully the machine to avoid extra loads in on the machine behind. I click on OK, and so the turbine has been curtailed. Another example, this machine perhaps is too close to certain houses. So again, under properties and under curtailment, I can apply a couple of noise curtailments. For example, here you can see the default setup, so all the parameters that can be used for noise curtailments. Again, notice that in yellow, windPRO highlights those that can only be used if you are going to run a time-based park calculation, which is what I'm going to do for this case. So in this scenario, for example, we can assume that this machine should be really quiet during the night. So I'll work on a time horizon 2207. And for all wind speeds and all wind directions and everything else. So basically every night from 22 to 7, this machine should be really quiet. And then I use, for example, a level 0 or mode 0 as Vestas calls it. And OK. And it will appear there. And we can make things even a bit more complicated. For example, we can say, OK, add another noise rule that instead concerns weekends. So I can change its name, weekends. What happens in the weekends? People are at home and they want it quiet. So what we can do is we establish that from Saturday to Sunday, anytime, this machine should be not as quiet as by night, but still quiet. So I choose a level 1, which is a bit more noisy than level 2, but still less than level 0. And I can change the priority. But of course, the noise, the curtailment of the night has priority on weekends. So, but that's something you can change by simply grabbing and moving these rows. Okay, so now basically I have 2 machines which have been curtailed, one for wind sector management and the other one for multiple scenarios of noise reduction. Let's try another thing, imagining that all machines must be curtailed, for example, for bat protection. And by the way, I can show you also this tool that allows me to, oops, I lost it, to select multiple machines in a single shot, right click, and what do I do here? I apply the so-called multi-edit in windPRO. There it is, under curtailment. You can see some individual curtailments have been already applied. You can actually show all the turbines and you can see which ones have been curtailed as we did before. You can also show by curtailment. So here you have the curtailment on noise and the curtailment on wind sector management. But let's go back to the multi-editing. So what I'm doing now is adding a rule for protecting bats. And bats, the problem is typically during summertime. There's very specific conditions, and they are the following. We only consider the summertime, and so you can enter the values here, or even you can do another thing, simply work by temperature. And so they will come out of caves only when the temperature is warm enough. So let's say at least 20 degrees. And when there's not much wind speed. So we're talking of wind speeds between 0 and 10 meters per second. If it's too windy, they will stay home. The same goes for precipitation. It must be dry. So here I'm entering precipitation intensity of 0 to 1 millimeters per hour, which is barely above drizzle, basically. And the most important parameter, of course, would be when during the day. And that, of course, means the problem starts, they come out of caves only at sunset, typically 1 hour after sunset, and they will go back something like 1 hour before sunrise, which is here. So from 1 hour after sunset to 1 hour before sunrise, when there's almost no rain and when wind speed is relatively low, and for warm temperatures, we have to shut down the machines. Okay, and here we have them. So remember, I'm under multi-editing. So what I do now is to click on apply, and windPRO informs me that 4 machines are going to be changed because of this. Yes, 4 changes applied. Okay, and close. That's it. So I have set a number of curtailments on my 4 machines. Now it's time to run a park calculation and see what we get out of it. I have a pre-run time varying park calculation. So at this point, it's just a matter of duplicating it. So I create a clone. And what you can do is, well, I'll change its name and I call it a curtailed time varying on long-term corrected measurements. And the simple thing I have to do is go to setup and activate use curtailment. This will open this new tab where you can finalize the setup. You can group again by turbine or by curtailment type. So you can see by curtailment type which turbines have been curtailed. And as I mentioned, as a last chance, you can even still edit the turbines. So what you can do basically is click on allow editing, and the button view will then become edit, and you can still modify the curtailment setup. Very important, at the bottom, you'll have the ability to choose the source of your data. Remember, we have implied not only wind speed and direction, but also temperature and precipitation in this calculation. So we need those signals. And I happen to have them in both cases from our EMD WRF mesoscale model output. So windPRO picks them already, and I just double check that those are the heights I'm interested in. So temperature at 100 meters and precipitation at 10 meters. It's again, it's the precipitation intensity. So it's millimeters per hour. I'm good to go. I click on OK and run the calculation. Final checkup, everything looks good. It will now call WASP to run a time-dependent park calculation. And it shouldn't take not even a minute. There we go. Result. And you're familiar with this, I presume. Right-click and print. I've prepared which are the pages, the sections of the report where actually curtailments will appear. So we just have a preview. Front page. Obviously, as you can expect, you'll find the result in terms of curtailment losses, and you'll have them here, 2.5%. And turbine by turbine, you'll have the curtailment losses as well. I believe the one with the larger losses is the one which is also is in particular noise curtailed. Next page is the production analysis. This is shown for the entire wind farm, and also here you basically see the contribution of the different curtailment losses, again, as you are familiar with, sector-wise, or more simply, the total. So you have wind sector management, noise protection, noise protection and BATS protection. This is given in power output, but you also have down here the same estimation in terms of percent. And down here, the familiar graph showing you energy production and wake losses now has the addition with a different color code to exhibit wind sector management losses, noise losses, and BATS protection losses. This is for the entire wind farm, but as you know, you can visualize this same page for each turbine, and I have already set that. So you can see here that different turbines will provide different results. Last, but certainly not least, the last page, which will show you the summary of your setup, so the curtailment assumptions. So here you can see which is the source of every signal I've been using running curtailments. And so for each turbine, which curtailment has been applied. If there are double curtailments, you can see the priority as it is illustrated here. And of course, the exact conditions applied to define those curtailments. I believe I'm way on time, and I'm pretty much done, honestly. I hope I've not been running too much, but I also believe everybody's quite tired. I can see a couple of questions, so I'll be very happy to answer if I can. So the first question comes from Jon Goldenbeld and asks, I normally apply curtailments in losses uncertainty module, so I can easily export results to file and get nice overviews of separate losses due to each category. How is the curtailment reported if I apply it in the turbine object directly? And the same for if I then also use time varying annual energy production calculations. True, we have had a number of curtailment options in loss and uncertainties before. However, you may have already seen that entering them in the each object and then having a park handling them is more user-friendly. I personally find it much easier to enter loss curtailments in the turbines and then let park handle them. In terms of output, remember that once you load a park result into loss and uncertainty, it will load also the corresponding curtailments, which will of course also appear in the corresponding report. Actually, I may be able to quickly do it. Loss and uncertainty. I load my curtailed park. Okay. These are the results. And if you go to losses, you will see the curtailments already included, which means that when you, I'm forgetting uncertainties, but it doesn't matter, and you have a look at the report, you will see your curtailments included there. So here you see the 1.4% of losses due to wakes, and a 2.5 due to curtailments, which is the gray. So you'll have exactly the same output you're familiar with, but I strongly believe that the approach we have now is way more friendly than what we had in loss and uncertainty, and you still have the option to enter the curtailments in loss and uncertainty. All that is still there. So hopefully this answers your question. I'm not entirely sure about the second part. The same for if I then also use time varying energy calculations. I'm not sure what you mean there, but basically, as I said, in case of time varying calculations, you have all possible scenarios as I've shown. And instead, if you use the wind statistic-based calculation, then you only have the ability to handle curtailments that are based on wind speed and wind direction. Hopefully this answers your question. Otherwise, you can contact me perhaps later. There's another question, which is, are you planning to add the Nachtzehn method for bad curtailments? I'm afraid I don't know what that is. Sounds very much German rules. I will find out, and perhaps we can keep in touch, and I'll get an answer on that. I'm not honestly familiar with that. I think there's new posts. Oh, yes. Okay. That's cool. I'm glad that there's plenty of people there still. For the time varying calculations, are the time series of each turbine available? And is it marked which curtailments are active for each time step? So for the time varying calculations, are the time series of each turbine available, and is it marked which curtailments are active for each time step? Obviously, you can extract the in a pretty big file the results from Park. I know for certain that the result to file in Park will give you this information. This will take some time to run. I know for sure that you'll get the results of curtailments in the result to file export. I can't recall testing it for the entire time series. I presume it's there because the information is there. So I believe that once you have run the calculation, for example, on an hourly basis, here I've been running on a monthly scenario. Let's see how long it takes. I run it now on an hourly scenario. Hopefully it won't take too long. And then we can try to have a look at what happens in terms of reporting. But let's see how long it takes. Meantime, I go through the other questions. Helen Willis asks, where do you find the information on sunset, sunrise, and precipitation data, as they do not come from the measurement data? Well, in my specific scenario, I have used the data coming from our mesoscale model output. So I've simply, some of them, as you know, are pre-run. So I simply load the meteor object that contains that information. And you also have the ability of running WRF on demand from windPRO. And in that case, WRF always provides a number of extra data sets apart from wind. And that includes Money-Nobuchov length for stability evaluations, atmospheric stability. It includes precipitation, and so on and so on. So, the information sunset and sunrise, that I presume would be based on the astronomical sunrise and sunset. So it's based on the time, on the local time on site. I got the result from my calculation. We can try to export result to file, copy to clipboard. That is going to be not too big because it's a 1 year long-term corrected. So now I need Excel. I paste there. And, no, I pasted the total. I need result to file. I need that one. Let me see if there's anything else. Park time varying. Copy to clipboard. Okay. Go back to Excel. Paste here. And now we'll see if we can find this information somewhere. It's going to be a pretty big file. Rewind, reduced. Let's see if we find it at the end. So this is sector-wise all the data. No, doesn't seem to be there. All corrections, blah, 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 blah. Nope. No, apparently I can't find it. So the way it looks like, it's not there. But obviously I can write a note on that because it makes a lot of sense to know when the turbines will actually be shut down. And thanks to Christian Wetzel for this, and we'll keep in touch and I'll give you more answers on also your previous question. Lara Jacobi asks, can you please show how you can pair noise and power in WindPRO? Certainly can. I open the catalog. I go for, let's pick Siemens, for example. Let's see. Here I have, for example, for this machine, I have 7 power cube datasets and 7 noise datasets. You can see them here. And you can see each of them has a name, level 0, 1, 2, 3, 4, 5, 6. And here you have, you can go manual and add power noise pairs. You can also let WindPRO auto-create the pairs. It will simply read the initial strings and it will create these links. And the default, it's up to you, of course, to verify that you have the correct pairing, but you can see it has been done correctly. One thing you may notice is that, unfortunately, not always and really each and every level number corresponds to lower and lower noise emission. So it is crucial that you verify that indeed, especially for, I think Vestas machines, they have a few situations where the noise modes do not correspond exactly to the numbering we have given, and we have, it gets more complicated. The auto-create will simply read the level indicated by our catalog, and based on that, it will assume that it goes from 0 to 5, meaning less and less noisy. However, these levels are read as they are if you're running, for example, a noise optimization, so trying to reduce the noise emission of the turbines. So it's important that you are sure that the sorting of these levels is indeed reflecting the less and less noisy emission of these turbines. So this is the way you can do it. You can then, of course, click on OK, and this will be saved as a user-specified option. We should be doing that ourselves and making it available. I'm aware of that. It's simply that all the old machines, they still have this old setup, so we'll have to enter them ourselves. So hopefully this answers Lara's question. There's another question from our friend Dhruv Direnda. We hear of him regularly. I'm happy to have you here, Dhruv. The question is, thanks for your thanks on my wonderful explanation. Maybe I have missed, can you let me know if is it possible to see how much is the improvement in park efficiency because of curtailments applied? The park efficiency, well, basically, I don't know if this refers to what I have shown before in my presentation. Let me show again the last slide, which is this one here. There you go. I don't know if you really refer to this. So you ask how much is the improvement in park efficiency? Curtailments usually mean losses. So what windPRO does in that case is to keep the wake losses somehow separated from the curtailment losses. And that's what the scenario illustrated here was trying to show. So in a situation like that, number one is fully operational. It gets a certain wind speed, obviously no wake losses. But and then number two receives less wind, and therefore it experiences some losses. In this case, we estimate something like 8%. But what happens if on top of those losses, we shut down the turbine for the whole day? And then, so the question would be, what is the curtailment losses, specifically the curtailment losses on number two? One might say, okay, the total is, the turbine is off, it's 100%. But the windPRO first takes apart the wake losses. So what we get out of there is, in terms of curtailment losses, the final answer would be 92%, because we take the 8% in wakes separate, even if the turbine is fully shut down. I'm not sure this answers your question. Please feel free to contact me later on if I have not been fully answering your questions. In some cases, at least the question from Christian concerns a specific method, which I believe may something which is considered in Germany. So I might have to investigate that with the developers. So I'm happy. 1, 2, 3, 4, 5, 6. And some more thanks from Jörn. Thanks. So if you have no further questions, I would call it a day and the conference. Hopefully you had a good time. And again, I believe you can track me from the conference tools and get the to contact me again, and hopefully I can get the full list of the questions from the organizers so that I can get back to you if I left something unanswered. Thank you very much, everybody, and thanks to the organizing team. It's pretty late. I would say out and over to you, Alexandra.
Thank you, Maurizio. Thank you for presentation. It was very clear, very informative, and I'm impressed with your knowledge of the bad habits and they do and what they like. It was really good. I think before we go back to our evening activities, celebrating the last day and celebrating the evening, basically, I want to say thank you to you and to your colleagues. It was really good to host you. I want to say thank you to all our participants, and I want to encourage absolutely everybody to come back to us with feedback about the platform, sessions, activities we organized, schedule of the event. As you know, it's the first time where we are doing the fully virtual tech workshop. So any feedback, anything constructive, relevant you can share with us, please do. And last but not least, I really hope to see you all next time in person in Naples. So have a good evening and we'll see you next year.
Thank you, everybody. Bye-bye.